So in this video, we want to graphically analyze the limit of a function that's displaying oscillatory behavior. So we want to find the limit as x goes to 0 of f of x when f of x is the function cosine of 1 over x. And we want to notice right away what the issue is going to be. We can't plug x into this function because f of 0 is undefined. And it's undefined because we would get 1 divided by 0 right here, and division by 0 is undefined. So we want to know the limit as x goes to 0 of a function for which we cannot plug in the value 0. When you look at the graph of the function, because our first step in graphically analyzing a limit is going to be to draw the graph of the function. So here I used GeoGebra Classic 5 to come up with the graph of the function. And it looks like the function values are bouncing between -1 and 1 as x approaches 0 from the right and as x approaches 0 from the left. And to think about what's going on, what we really want to do is think about the function composition that's happening here. We really have a function that's like f of g of x, where g of x is the function 1 over x. 1 over x is being input into the cosine function. And a big question to ask is, what's the behavior of 1 over x as x goes to 0? In other words, what's the limit as x goes to 0 from the negative side of 1 over x? So if we approach, so right here, this graph here is the graph of just 1 over x. And we see that if we approach 0 from the negative side, that the function outputs are going to negative infinity. Similarly, if we take the limit as x goes to 0 from the positive side graphically, so we move our inputs closer and closer to 0, we see that our function is going up the vertical asymptote x equal to 0, and the outputs are becoming infinitely large. So in general, the limit as x goes to 0 of 1 over x is going to be either plus or minus infinity. The outputs to the function 1 over x are becoming infinitely large positive, infinitely large negative. And so then if we just think about the cosine function by itself, well, the cosine function, we know that the range of it goes from -1 to 1, and that it goes from -1 to 1 and back to -1 every 2 pi radians, or about 6 radians roughly. So if 1 over x is going to infinity as x gets closer to 0, how many times in infinity are you going to get 6 radians? Well, it's going to happen infinitely many times, and because 1 over x is sweeping up its vertical asymptote to infinity and sweeping down that vertical asymptote to negative infinity very rapidly, it's going to take on 6 radians faster and faster and faster. So that's what's going on here. As x goes to 0, because 1 over x is going to plus or minus infinity, the cosine of 1 over x is bouncing between -1 and 1 infinitely many times and increasingly at an increasingly rapid speed, which is why the software is having a hard time drawing the picture of it. It just looks like a solid block of blue graph right here. So the conclusion is, in this case, the limit as x goes to 0 of the cosine of 1 over x, we would say in this case that it does not exist because the cosine of 1 over x oscillates between -1 and 1, between -1 and 1 infinitely many times. As x approaches 0. And that's as it approaches 0 both from the left-hand side and the right-hand side. So neither one-sided limit exists. The function's constantly oscillating between -1 and 1.